Okay, welcome back. We're starting a new unit, or this is Unit 6. This is Lesson 1. Ultimately, what we're going to be starting off with for Lesson 1 is just expanding binomials. What that means is a binomial, as we talked about before, means two terms. And what we're going to do is we're going to multiply two terms together that are inside brackets. So what it's going to produce is something that looks like this, ultimately at the end. And this is called a quadratic. Our next two units are probably the most important units of grade 10. So it's really important that we spend our time understanding what's going on, because quadratics is where you start in grade 11 in the college or the mixed course. And ultimately it's the foundation of what you're going to be doing for not only the rest of this year, but all of next year. So we're going to be using a method to start off with expanding, which is called FOIL. It's this acronym that stands for first, outside, inside, last. But I'm going to call it like this rainbow method that you're used to. And that's going to be a little bit easier. But ultimately what it is we're going to have two binomials, as we can see here. We have 2x plus 3 and x plus 1. And all we're going to be doing is taking this first term and multiplying it by the first and last term inside the second bracket. And then we're going to take the second term and we're going to multiply it by the first and last term inside the bracket. I like to use these arrows. I find that they help me stay organized a little bit better than just using that acronym first, outside, inside, last. And then maybe that I'm going to write down for myself right now that I'm multiplying. The biggest issue that students have with learning multiplying binomials is that they add. So just remember that every time that we do this, we're going to multiply. So when we multiply, we're going to multiply the numbers and basically add the exponents of our variables. So 2, we'll follow this arrow across, 2 multiplied by 1. So 2 times 1 is 2. But there's an x here. X times x, when we multiply x's together, we add their exponents. So this is 1 plus 1. I'm maybe making this a little bit more complicated than it is, but you'll see how fast and how easy it is once we get going. I'm just over explaining it so that you truly know what's going on here. The next part, 2x times 1. Well, 2 times 1 is again 2. And there's no x with that 1, so there's just 1x. Now, do you see how, like, when I'm expanding, when I'm multiplying, I'm not writing brackets anymore? Because essentially, when we multiply, we break the brackets. And we know this from before, from grade 9, when we would do things like 2 multiplied by x plus 2. We would go 2 times x, 2x. 2 times 2, 4. That's from grade 9. Now we're just basically doing the same thing, but instead of multiplying it just once, by that 2, by this 2x, well, guess what? We have another number to do. So let's keep going. 3 times x, 3x. 3 times 1, 3. Now we're almost done. It's that easy. The next step is to basically collect any like terms if we have them. Like terms mean that the letters have the same degree. So for this 2x squared, do I have any x squareds in the rest of the expression that I've written down? Nope. So it's just by itself. This 2x, though, I can add to this 3x because they're the same. They're like terms. Now, be careful. Before you were multiplying, now what operation are you doing with the 2x and the 3? You're adding them together because that's what it says, 2x plus 3x. So that's 5x. And at the end, there's no other constant or just number by itself that I can use. So it's just 3 at the end. Now you're done. Now you have something that looks like the format which I've shown you earlier. This ax squared plus bx plus c, which is going to be new. We don't need to know it right now, but ultimately we have something here that's a quadratic. I know that it's a quadratic because it has a leading coefficient of 2. That's what we're going to learn. Right now we're just worried about being able to expand and turn it into standard form. So let's keep going and let's look at the next example here. Negative x plus 2 times 3x minus 4. Now what I like to do, because sometimes I get confused here, is I like to write in the number if it's not written, especially when it's a 1. So negative 1 times 3 is negative 3. X times x is that x squared. But you don't separate them, you keep them together, right? So that's a negative 3x squared. Then we'll do negative 1 multiplied by negative 4, which is positive 4x. Then we'll do 2 times 3, which is 6x, and 2 times negative 4, which is negative 8. Do we have any like terms here to collect? Yeah, it's usually going to be the middle terms, right? So we'll put them together. 4 plus 6 is 10. And that's it. We're done. Don't make this more complicated than it is. So let's see another example here. 4x times negative 4x. Remember, times, multiply. Don't say 8. It's not 8. 4 times negative 4 is negative 16x squared. 4 times negative 3 is negative 12x. Negative 2 times negative 4 is positive 8x. Negative 2 times negative 3 is positive 6. The two terms that will go together is the 12 and the 8. So we've got negative 16x squared minus 4, x plus 6. Now let's look at another example here that we might not be used to. So it's asking us to, we've got a square binomial here, and it's asking me to do the same thing that I was doing above here, which is to expand and then simplify. Simplify means to collect like terms. But how am I going to multiply 3x plus 2 to the power of 2? I'm not going to just take the 2 and put it to the 3x and the 2. Don't do that. I will not show you that. I'm not going to teach it to you. But what I want you to know right now is what that means. What does the power of 2 mean? What if I wrote this, 5 to the power of 2? Does that mean 5 times 2? Absolutely not. It means multiply it by itself 2 times. So 5 times 5, 25. So what about if I wrote 5 to the power of 3? What does that mean? It means 5 times 5 times 5. 3 times. 1, 2, 3. So how many times do I have to multiply 3x plus 2 by itself? 1, 2. I have to multiply it 2 times. So all this is telling me to do is to write out this bracket twice. Now that I've written it out twice, I can use the method that I taught you before of FOIL, or my rainbow method here. 3x times 3x, 9x squared. 3x times 2, 6x. 2 times 3x, 6x. 2 times 2, 4. Simplify, which means collect like terms. 9x squared plus 12x plus 4. Now we're going to look at one of the word problems that we can have, and then we'll be done with this lesson. So it says a rectangular park has a width equal to x plus 1 and a length equal to x plus 3. Both measures are in kilometers. A is asking me to draw a diagram to represent the situation. So it said a rectangular park. So for A, I'm going to draw a rectangle, and then I'll label the sides. It told me that the width is x plus 1, and that the length is x plus 3. I finished the first question. B is asking me to find the quadratic expression that represents the area of the park. Well, what do you know area of a rectangle to be? What formula is it? It's length multiplied by width. So all we're going to do is take our length, which is our x plus 3, and we'll take our width, x plus 1, and we'll multiply them. X times x, x squared, x times 1, 1x, 3 times x, 3x, 3 times 1, 3. We'll collect the two middle terms to simplify our expression, and we're left with 1 plus 3 which is 4x. So we've got x squared plus 4x plus 3. Now we're done question B. Question C says, calculate the area if x is 2. So now for C, we'll use our equation, and we'll fill in x with 2. So our area is x squared plus 4x plus 3. X is 2, so 2 to the power of 2 plus 4 times 2 plus 3, because all the x's have now become a 2. You're going to type this into your calculator in one shot if you have a 2-line calculator to solve. If not, you're going to have to solve for each of these terms separately, then add them up. So for me, I'm just going to type it into my calculator, press equal, and find that the answer is 15. Now, when you're solving for your area, it's important to know what your units were to be able to write them to the power of 2. So my area is 15 kilometers squared. That concludes the first lesson.